Welcome to Easy Gates, Gate 22 Instrumentation Solutions. So next problem, question number 54 from the master paper. That's a given circuit. Given circuit A with the currents I1, I2 as shown. Okay, so circuit is given where the current I1 is mentioned and I2 is also mentioned as 2 amps and 1/3 amps. The current I3 in the circuit B is, so round off to 1 decimal place. So two unknowns, R0 is not given, this R0 also not given. So first you need to think in what way you can approach the problem. There are n number of routes you can think of, Norton's, Thevenin's, mesh, nodal, so many thoughts will come into mind during the examination. The best way to proceed for this problem is, so he's having only one source here, but he's having two sources here. And the clue here is, so 16 is the integer multiple of 8 as well as 16 is the integer multiple of 48. Suppose if 8 is not given, then you will think immediately there is a link between circuit A and circuit B. We can approach the problem by principle of reciprocity. Yes, in fact, we're going to approach the problem by using two routes. One is, it has to be, that is the only way. Okay, that idea should have, you should have got it during the examination itself. If not, the life is a little tough. It was little tough during the examination. Fine then. So that's a way to proceed. So we have to bring reciprocity as well as principle of superposition into the play. Then it is very easy problem to approach and get the solution instantly. And you know very well, it's all about the idea what we get in the examination. That is the one going to decide our time taken for every problem. Okay. So that's the only hint given. So he has given the hint that we should not look for the value of R0. So we have to play like this. Okay, so let me go with the given data. So this is given, for example, it is 16-volt battery connected here. So 16-volt connected here, the current is equal to 2 amps here, and this current is given as 1/3 amps, provided this is shorted. Okay, take that way. So that means you can treat this as your excitation terminals, this is your response terminal. Suppose if we swap it, what you're going to get? If you swap it, that means this is going to become your response terminal and this is going to become your excitation. If you give 16-volt here, then again, what is this current? Whatever the current, okay, you're getting earlier, yes, you will get it. What is that? You just swap. What is the current you're getting here? You're getting the current is 1/3. Therefore, this current is also going to be 1/3 amps. Okay, if it is 16. Suppose if it is 48, so multiply by 3. So this is going to be 48 volt. If you give 48-volt excitation here, then that will result in into 3 amps current. That is going to be 1 amp. So 48-volt exciting the circuit as by using the principle of reciprocity and linearity. So if it is 16-volt, you will get 1/3 amps at the response terminals. Since it is 48 given, so it is going to contribute 1 amps. Okay, so contribution, this is exactly the superposition. The given circuit has two sources. One is 8-volt, another one is 48. So if you activate 48 alone, the current is going to exist this way. So let me call this as the component I31. Okay, first response, let this is the V1 and this is the V2. So V1 contributes first response, then will enable V2 will get the second response. Okay, so as per the given direction, I3 is given in this direction. So what current you are getting now is should be in the same direction. So what is your I32 then? I31 then means, since the current is existing in the opposite direction, so you have to take the current as negative. So this is the current given as I3. So this is my I31 first component. Therefore, I will take I31 as -1 amps due to 48-volt excitation. I am calling it as V1. So next, enable the second source, that is only 8-volt. Okay, for that, this is once again the reference. Keeping this as a reference, now let me excite the circuit by 8-volt battery. So the excitation points remain same and the response points remain same. So if I give 16-volt here, I got the response here as how much? Response here is how much? 2 amps. When 16-volt has contributed how much? 2 amps. So now if I decrease my excitation to 8-volt, so it is divided by 2. Therefore, the current is also getting divided by 2. The current is going to become 1 amps. That's your current I32. Let me take. So this is the voltage V2. So V2 alone acting in the circuit as per the reciprocity gives current is I32 equal to 1 amps. Okay, but this current is going to be, so this is 2 amps earlier. So this current is going to be 1 by 3 and this current is going to be what? 1 by 6 amps now. Okay, but anyway, the problem is not with respect to this current. The problem is only about the I3 component. Yes, you can happily conclude the problem if both are excited. If both are excited, that means, so here you give 8 volt and here you give 48 volts. So 48 volts makes this current of 1 amps and 8 volt make this current of 1 amps. Therefore, the net current I3 is equal to I31 plus I32. I31 plus I32. I31 is already negative. So it's going to be minus 1 ampere and this is going to be plus 1 ampere. So the correct answer is 0 amps. So you have to feed it's up to 1 decimal place. So answer must be given as 0.0. That's a correct answer for this problem. Another interesting one, little play by the designer because he is forcing us to play with both reciprocity as well as superposition. That's one of the interesting problem in the instrumentation K22 paper. Okay. And hope you enjoyed the content delivered and subscribe the channel and also look for the next problem. Thank you.